Hi, it's Pedro from the Tuist team, and I would like to talk about graphs today. You've probably seen me a lot talking about graphs and how cool they are in Tuist, and I would like to tell a story. So let's talk about Xcode and projects. So when you create an app, what you get is an Xcode project, which is something like this. So your project contains a target, which represents your app. Maybe there is a test target that depends on your target. And as you grow, you start creating more of those targets. So let's say my app now depends on this module, and I have this other module that is a transitive dependency. Maybe the two of them depend on the same module. And in that case, we have to make it dynamic so that we don't end up with duplicated symbols, potentially. And as you see, if this grows, it really gets very hard to get a picture of the graph of how things depend on each other, because information about dependencies is usually in build phases and build settings, so it's not straightforward. What that usually leads to is 1, 2, maybe 3 people in the team know about the graph. They have it in their minds. That's not great. That needs to be explicit so that you can get this overview, you can optimize it, and you can reason about it. And that's the problem. Like when it grows a lot, it's really, really, really hard to reason about it. And it's not a matter of understanding how Xcode works. It is impossible. On top of that, Xcode project internally has a file called pvxproj that codifies all these different changes that you apply to projects, and that is the classic common of Git conflicts in Xcode, which is not ideal. So when people were like building like this for a while, they quickly realized that if you wanna extract some of those pieces and like share that across projects, it was a very manual work. Someone, the Cocoapods crew, had the brilliant idea of helping developers with that. So they came up, inspired by Ruby, with the idea of having pods. So we have a pod A, which is defined in a pod spec that depends on pod B, and A also depends on C. The information about those pods is stored in the Cocoapods registry. And what they do in order to integrate those pods, which are not projects, is when you do pod install, they generate another project here called pods. Then they create a workspace XC workspace, and through build settings and build phases, and build settings are defining xcconfig files, they instruct the build system when it compiles your project to build and link the pods. So you can think of it as some kind of build time instructions that basically Xcode implicitly resolves the graphs. It knows it has to compile the pods first, and after that it does all the linking and all of that. So that's what the industry continues to use, and it was the only option back then, and still a very novel idea of like moving away from Xcode projects and that explicitness, because then that opens the door for optimizations. Also, Cocoapods has this set of plugins that people can develop to do something with the graph and the way it integrates into the project. So eventually, Carthage came with a different approach to dependencies. So what changes here is that there is no registry, and dependencies are either binaries or source code that is decentralized across repositories. So we continue with the alphabet. We have T repository, and we have the source code inside, or binary. T depends on E. Same thing. We have either binary or source code with an Xcode project that Carthage knows how to compile. And we have the F dependency. We don't need a registry because Carthage knows how to resolve the dependency graph asynchronously. And then when you tell Carthage to pull the graph, what you end up getting locally is a set of binaries. If the dependency doesn't provide a binary, then Carthage gets a project in the repo and it compiles it for you. So there is a graph. However, they turn the graph into something flat. Those binaries still depend on each other, but you see a flat list of targets that then it's your responsibility to integrate. So from your project targets, you need to somehow define dependencies with those binaries that Carthage has given you. These are inconvenient. Like, it's easy if your project's dependency graph is small, but if it's large, then you need to be aware of the structure of the graph to be able to integrate the binaries well. Because if you don't, then you end up with the dynamic linker trying to find missing frameworks, and that takes time to figure out the why, because you cannot see the graph from your project. As you know, eventually we had Cocoapods, Swift Package Manager joining the family. So they started with same approach as Carthage. So we don't have a registry. So we are gonna resolve the dependency graph in the same way, decentralized across repositories. So we have something like G repo. In this case, there are no binaries, so we have the source code there. Then H here. And then I. Again, this is source code. We don't have binaries here. So the first version of the Swift Package Manager didn't have an integration with, you couldn't integrate your project with the Swift Package Manager. So what they did was they provided a method that gave you an Xcode project. So they take the graph, they generate an Xcode project, with your targets inside. So you ended up getting something that you could open with Xcode and build something with it. So people started building frameworks, libraries, CLIs, also Tuist started like that. People wanted a way to integrate those. People wanted that. Like, I would like to use my packages from my project, and people had to wait for that. I don't remember for how many years, but it was such an exciting thing when Apple presented it. So what did they do? So they said, well, they could have done the same as Cocoapods, turn that into a project and then integrate it in the same way Cocoapods did it, probably in a more convenient way for developers, because we should not forget that Apple is the company behind Xcode, so they can really make things more convenient. Again, same approach as Cocoapods, but nicer from the UI point of view. But they did something different. They said, no, we own the build system of Xcode. So let's do the following. So this is the project, and I'm gonna add the build system here. Build system. And the Swift Package Manager. Probably here, this is me assuming how Apple might be doing things, but this is based on what I've seen, how things work. So when you open Xcode, then Xcode calls the Swift Package Manager. Well, actually, before I share that, so your project declares a dependency with those packages. No, it says I depend on G, I depend on H, and I depend on I. So when you open the Xcode project, then Xcode sees that your project depends on packages, and then it resolves them through the Swift Package Manager. So the Swift Package Manager says, okay, so I resolve them, and then I store them in your system somewhere in derived data. So you end up having the source code locally. This is when you try to open a project with a lot of packages, you will see that now Xcode, if your derived data is clean, you will see that it tries to resolve dependencies and store them locally. That's what it does. It feels very much like Gradle, which I find very annoying, but it is what it is. So we have that locally, and then when you try to compile the project, then the project, well, Xcode, goes to the project, reads the project, goes to the build system and says compile this. And as part of the process of going to the build system, it uses the Swift Package Manager to know where dependencies are and how they should be integrated into the project. So it's kind of like build system and Swift Package Manager talking to each other to figure out a way for your project to be aware of the dependencies and integrate them successfully at build time. And this is important. It happens at build time. Dependencies are resolved at launch time, but they're integrated at build time. And because all of that is inside Xcode, all that logic and the way the build system talks to the Swift Package Manager, it's really hard to optimize. So it basically depends on Apple introducing optimizations at build time. Unfortunately, the community cannot do much about that. Well, we can, but it requires you to move to different build systems, which is what solutions like Bazel and Bag do. So they replace Xcode build system. They have their own syntax for describing projects, and they can optimize things. So summarizing the status of graphs and how they are used to bring dependencies, Cocoapods centralized and integrates to an Xcode project that is added to a workspace. Then Carthage, there is a dependency graph that it's turned into a flat list of binaries that you have to manually integrate. There is Swift Package Manager, which is decentralized as Carthage, but unlike Carthage, you get source code. And Xcode does the integration of those packages at build time. So, and if there is any bug in that logic, like there has been, then the compilation of your targets that depend on packages fail. So you know what it means. You file a radar and you wait for Apple to fix it for the next version. So let's see what Tuist does with graphs. So Tuist has a way for you. It provides you with an API, same as Cocoapods or Swift Package Manager, to describe your project. So you say, I have A, that depends on B, B depends on C, A depends on D, and D on C. So you describe that. You say I have a project, projects have targets, targets are of this type, they have these sources, and then we generate a project, a set of projects. You can also define group projects and their workspaces. So we end up getting an Xcode project. So obviously, how that looks internally is how we saw before. So same thing. We have A, B, C, and D. So we end up getting the same. You can run one command, generate, and then your project is generated. So this is important. We need a project, because otherwise you cannot work with Xcode. So we always need an Xcode project, and we always need an Xe workspace. We always need the format that Xcode understands for us, for the developers to be able to work with the project. Cool, Pedro. What are you fixing with that? Well, let's talk about a few things. What if this? Oh, sorry. What if this dependency here, this one, is incompatible? Like you're trying to depend on a framework from a different platform, or you are trying to depend on something that would lead to duplicated symbols. Well, what happens is very easy. We don't generate the project. Why would we generate a project if we know it's not gonna compile? You're gonna waste your time. So that's something that Xcode does at build time. Sometimes they don't do a good job, so you end up waiting for, 10 minutes until your project compiles, and then you realize that you wasted your time, basically. So that's one thing. So what else do we do? So let's say you plan to work on framework B. You want to focus on that framework. So we say, cool. So if you plan to work on B, you also need C, but you don't need the others, Pedro. If you really want to focus on B, give me B and C. Don't give me the other. Voila. So that's what we end up getting. So here we end up having that. And the way you tell that to Tuist is through a command called focus. And you say you want to focus on B, and that's it. You get a smaller project, and when the project is smaller, Xcode is faster, and potentially also the build times. So I'm gonna take some step back to see the graph that we have initially. So this one. So we can validate the graph. We can optimize the graph. What else? What else can we do? So at some point we realized that developers wanted to add dependencies. So we gave them an API for describing dependencies, and we did it in a way that is standard across all the package managers. We didn't want to reinvent dependency management for Swift. So we said, oh, you have a Carthage framework. Fine. That framework depends on another framework. Fine. Oh, so you depend on a package. So what? That's perfect. Then this one depends on another package, and then this one depends on another package. But oh, you also have Cocoapods. Oh, fine, perfect. So we also have some dependencies here. So that's Carthage. That's packages. That's pods. So developers were able to describe their dependencies in a dependencies.swift in the same place for the 3 types of dependency managers. And not only that, so they were able to declare that the targets in their project depend on them. So what we end up getting is one single unified graph. So when we validate the graph, we validate everything together. So for example, if there is an incompatibility here between your target and external dependency, we don't generate the project. But we go beyond that. So if you plan to focus on C, we are going to generate this small graph in the Xcode project, because that's in the end what you're interested in working on. But even more, what if you want to focus on one of those pods? I say, well, Tuist focus I, and that's it. And I focus on that piece of the whole graph. And this is very powerful because you open Xcode, and Xcode is way faster than if you open the entire graph in Xcode. And let's talk about one final thing. Before I move on to that, this is an important concept to take away. So there's one graph. Everything is part of something. We don't have to mess with build system. We don't have to mess with figuring out a way to integrate dependencies into your Xcode project. We have a graph that we know we can optimize, and we can lint, and we can validate, and we can do many things with it. And that is powerful, very powerful. And that most of the features on Tuist depend on this concept. And the one feature which I think is key and is one of the features that we're investing a lot in is caching. So, as you know, like most of the times in large code bases, you spend your time working on one of the targets. For example, let's say I'm part of the team B. We have a framework that represents that B feature of my app, and then I'm working on this one. So when you compile B and you don't have anything derived data, you know that Xcode has to compile the dependencies. It tries to use all the power of your system, do things in parallel. Well, we don't need to compile this, but this one, and this one, and then B, and then B was successful. Xcode will keep a copy of those artifacts. For example, if you don't change anything in them, and you're only changing files in B, it shouldn't be compiling the other targets. However, sometimes you need to clean the build because, I don't know, builds are failing, or you get some weird errors, you don't know how to debug. So you do clean, and every time you do clean, you delete all the files that derive data, so Xcode has to start compiling things again. And if the graph is large, it can be a waste of time. So what does Tuist do? So we go through your graph. There is a command that says cache worm, and then we take each of those frameworks and we generate binaries out of them. And we store them both locally, but also remotely for the people in your team to be able to use them. And this is me painting binaries. Let's say this here. And see, this one here. So now I have a binary representation of the state of each of my binaries, and those binaries are identified. They have a unique identifier that is calculated based on the content of the target, well, the settings of the target, the attributes, the files, and also the unique ID of the dependencies of the target, such that if you change anything there, the identifier, the fingerprint will change. So next time you tell Tuist, I want to focus on B, Tuist will generate an Xcode project, because again, that's what you need to be able to work on with Xcode. It will create the target B here, but now it will replace everything else with binaries. So we get a binary here, 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 also here, and also here. So now you have just one target that depends on a set of direct and transitive dependencies. So all the time you are compiling B, even if you clean derived data. And that is a huge time saver. One of the reasons why I think Tuist is amazing, because it solves the problem of not compiling things that I don't want to compile, that I don't need to compile, without having to replace the build system, without having to reinvent anything. We just use generation phase, Xcode project generation phase, that does optimizations for you. And that's one of the most compelling reasons to use Tuist. Note that also the caching also works with third-party dependencies, so you can cache your packages, you can cache your Cocoapods, and that's very powerful. So yeah, that's what I wanted to tell you. It was kind of like the story of graphs and dependency managers and Xcode projects, everything kind of mixed together. And I hope it gave you a good understanding of how graphs are or relate to projects, and how the different package managers and tools use them, including Tuist. Thanks a lot.